So we're going to talk about the chain rule now. And in the chain rule, you have two functions. So we have f of x is equal to 3x plus 7, and g of x is equal to x squared. Then we're going to find f of g of x, and to find that, we're going to take the x squared, which is g of x, and plug it into the f function. So then we have 3 x is x squared plus 7, so this is the f of g of x. So we're substituting one equation into the other one for the x value. The definition, if y is equal to f of z and z is equal to g of t, and both are differentiable, this means that the function is continuous over some specified period. Then the derivative is y is equal to f of g of t. Now the derivative of that is equal to f prime of g of t. So now you're taking the derivative of g of t times g prime of t. Okay, so here's what we're doing. We're plugging g of t in first, and then we are taking the derivative of it. So let's start off with an easy one, e to the x. The derivative of e to the x is e to the x. The derivative of e to the 5x is equal to 5 times e to the x. Okay, now here's an ugly one. This one is the derivative of a square root. So what we're going to have to do is take the square root off, raise that to the 1/2 power. When you do that, you have two equations in one. So what you're going to do is you're going to take 1/2, multiply it in front like I did here. Then we take 1/2 minus 1 is equal to negative 1/2. Then we take the derivative of what's on the inside, 3x squared. And we combine them, or you can leave it just like this, but 3x squared divided by 2 times x cubed plus 1 raised to the 1/2 power is also a good answer. If I have this one, taking the derivative of x cubed plus x quantity squared, you take the 2 and bring it out in front and leave this alone, just write it just like it is, then you take the derivative of what's on the inside. So that is 3 times x squared plus the derivative of x is 1, and so you multiply it. And you can use this as an example. I put in 2 and 2.01, and I found the derivative of that, and it's equal to 1/2. I found the derivative of this, which is 1/3, and so forth and so on until I got to 1/5, which means that the derivative of the natural log of x is 1 over x. But when you have something in the x spot that is something different other than x by itself, you're going to have 1 over g of x, whatever's in this x spot, times g prime of x. Okay, so let's do a problem. Here I have natural log of 4x plus 1 quantity squared. Okay, so we are going to do what we did before. Here's the chain rule. So we're going to take this 2 and put it out in front. 2 times natural log of 4 to the 4 times x plus 1. We can rewrite it, is basically all we're doing there. Now let's write the derivative. So we have 2, this 2, times the argument right here, which is 4x plus 1, times the derivative of what's on the inside, which is 4. 4 times 2 is 8, so 8 divided by 4x plus 1. Now here's the power rule, exponential rule, g prime of x, and actually that g prime of x goes down here. So let me make this bigger so it'll fit back over here. And the logarithmic rule. So the power rule is real simple. X to the n is equal to n times x to the n minus 1. Using the chain rule, it's going to be n times f of x, whatever that is, times n minus 1. And then the exponential rule we know is a to the x, natural log of a, but we could have a to the g of x. So we could have like 3 to the x up there. So that makes that another function. So now we have a to the g of x times natural log of a times g prime of x. Derivative of e to the x is e to the x, but if the x has anything added to it, like like 5 to the x, 5x, then you have e to the g of x that always stays the same times the derivative of the exponent. e to the kx is equal to k times e to the kx, for k is equal to a constant and not equal to 0. Logarithmic 1 over x for natural log, and then if you have a function here, natural log of some function, you're going to have 1 over g of x times g prime of x. And we'll do a few problems here. Number 3, t squared plus 1 quantity raised to 100. The 100 comes out in front, and now you have 99. And notice t squared plus 1 did not change yet, times the derivative of what's on the inside. And then you can multiply those to simplify it. Natural log of e to the x plus 1, you have 1 over e to the x plus 1, that's the whole entire argument, times the derivative of what's on the inside, which is e to the x. Find the tangent line of the equation. F of x is equal to x minus 1 quantity cubed at x is equal to 2. The first thing we do is find the point. The second thing we do is take the derivative and plug in the point to get the slope at x is equal to 2. The new function of the tangent line equation, f of 2 plus f prime of 2 times x minus 2. 1 is our value, 3 is our slope, x minus 2, and then you simplify.